Hi, everybody. Welcome to video 10. So we're getting the double digits. Video 10, we are still going to be practicing Stoic. We are going to be Stoic homework number 2. So now we're going to go over that first page of homework number 2. We're going to go over part of the first page. I'm going to start kind of releasing you to do a little bit more on your own. And then you'll finish off that second page and the rest of problem 1 on your own. But again, we are in homework sheet number 2. Those are all linked in your planners and in all of your activities. So you can follow along in there and kind of see the problems that I'm reading about. Okay, so Stoic homework number 2. We start off with a story problem. You're washing dishes in your sink and notice it is taking a while for the water to drain. You remember learning that baking soda and vinegar can help unclog drains, so you dump 25 grams of baking soda into your drain. So we are looking at a chemical reaction of baking soda, which is NaHCO3, and vinegar, which is CH3COOH. And your reaction produces CO2, water, and this salt thing, NaCH3COO. And we know that we are starting reaction with 25 grams of baking soda. Oops, there is no C in baking. So here's our chemical reaction. We are starting our chemical reaction with 25 grams of baking soda. First step, balance it. Now, this is a long reaction. It's actually balanced. So it's all just ones out in front. When you go through it and you total up where all the oxygens involved and all the sodiums and hydrogens, it's all balanced with ones, and that's already balanced for you. So balanced chemical reaction, we are going to begin with 25 grams of baking soda. Getting into some real world application, I want us to calculate what volume, because most of us measure liquids in volumes, of vinegar will you need to dump in your sink to react with all the baking soda. So we know we have 25 grams of baking soda, but we want to know how much vinegar do we need. Start with your known. I have 25 grams of baking soda, which is the sodium one. From grams, I can go to moles. Now, usually I do actually go all the way through before filling in numbers. From moles of one substance, so from moles of baking soda, I can go to moles of another. From moles of that substance, I can go to grams of that substance. Now, my final goal is what volume of vinegar will I need? It says it in the problem. The density of vinegar is 1.05 grams per milliliter. So after I get my grams of vinegar, I can go to milliliters of vinegar using my density conversion. just for the sake of room, I'm going to get to grams first. So moles to grams of grams of baking soda to moles of baking soda. 1 mole, and then you got to get the molar mass. So 1 sodium plus 1 hydrogen plus 1 carbon plus 3 oxygens. Molar mass ends up being 84 grams of sodium bicarbonate. Mole ratios, I'm going to put it in red, but everything is 1. For every 1 mole of baking soda used, you need to use 1 mole of vinegar. And again, using molar masses, we know that 1 mole of vinegar, add up all the weights, weighs about 60 grams. So, periodic table, coefficients. Take all those numbers, get them into a calculator. So 25 divided by 84 times 60. And you end up with, we have produced 17.86 grams of CH3COOH. Now, I need to get to milliliters. Normally this would be done from grams I can get to milliliters via the density conversion. So there are 1.05 grams of vinegar for every 1 milliliter of vinegar. So divide that whole thing by 1.05, and we end up with a final answer of there are 17 milliliters of vinegar needed to react with all of the baking soda that you've dumped down your drain. So, good real-world application. If you dump down 25 grams of baking soda, you need to add 17 milliliters of vinegar in order to react with all of that. So, this was kind of the trick question for this problem. Questions B, C, and D. How many moles of CO2 will you make? This one is more similar to what we've been doing. Start off with what you know. So I know for sure that there are 25 grams of baking soda. 25 grams of NaHCO3. And you'll get used to this, grams to moles. Moles of one substance to moles of another. And actually, the question asked moles of CO2. I got to moles of CO2, I'm done. This is your molar mass, so those numbers from the periodic table. This is your mole ratio, so your coefficients from out front. And then this is a pretty simple, straightforward calculation. 25 divided by 84. I am going to make about 0.29 or round it to 0.030 moles of CO2 in my chemical reaction. Again, make sure you check where you're going to. So here I was going to volume, given a milliliter conversion, so I needed grams and milliliters. Here I'm just going to moles. We're not necessarily always going all the way to grams. So that was B. Question C, how many grams of water will be created? Start off with what you know. I know I have 25 grams of the baking soda. From the grams, I can go to moles, so grams of NaHCO3 to moles of NaHCO3. The molar mass of NaHCO3 is 84. From moles of one substance to moles of another, so moles of baking soda to moles of water. All of these were a 1-to-1 conversion. And then from moles of water to grams of water. And the molar mass of water, you'll get to know there's 18 grams per 1 mole. Type it in, 25 divided by 84 times 18. I am going to make 5.36, sorry for my handwriting, 5.36, actually I need to round it more, so I'm going to make 5.4 grams of water in this chemical reaction. This was kind of, actually, I'm going to do all of the first page. I said I wouldn't, but just so that I can get us kind of through one example of all of these in a story problem. We've gone to moles, we've gone to grams. Last thing I want to calculate is how many molecules of the salt, which is the NaCH3COO, will be produced. So now you'll have some practice in remembering going to molecules. They all start the same. These problems are repetitive, so it's really also important that you get that first step right. Start with what you know. I start with 25 grams of the sodium NaHCO3, grams to moles. Yes, you do have to write the step every time, because each calculation has to be complete and valid in order to get credit. We can't have these fragmented calculations. If you ever get into a lab class in college and you do a lab notebook, you will need this level of calculation and this level of detail at every step. So again, same thing, grams to moles, moles of one substance to moles of another. This time I'm going to the salt. Everything in this is a 1-to-1. And this time I'm going to molecules. Molecules, atoms, and particles. Those are keywords for Avogadro's number. So 1 mole of any substance contains 6.02 times 10 to the 23rd molecules of that substance. Then all you got to do is type it into your calculator. 25 divide 84 times 1 divide 1 times 6.02 times 10 to the 23rd. And you end up with 1.8 times 10 to the 23rd molecules of that salt, NaCH3COO, are produced. So that's page 1. Page 2 is similar scenario, but I want you to go ahead and do page 2 on your own now.